Hey everyone, welcome to another edition of Philip in the Clouds. Today we're going to be talking about something a little bit different. I was working on improving the duckdb ibis.read function to kind of make it more general, and I kind of ran into a problem where I needed to get the metadata from a Parquet file, whether it was on disk or behind a URL, and I needed to be able to do this without using a particular backend. And so this is kind of what I came up with to do to get the Parquet metadata from behind a URL, uh, as cheaply as possible. So I've set up a little problem definition here, and we're just going to kind of work through the problem bit by bit. If it turns out to be too long, I may split the stream into another video for next week. Let's see how far we get. Okay, so in my text editor over here, I've got a doc string. It says given a URL pointing to a Parquet file. How do I get the schema from that file as cheaply as possible? This is the problem we're trying to solve. I was testing with a 75 megabyte file, which is not huge, but re-downloading or downloading a Parquet file of 75 megabytes every time you need to do something with that file, like get the metadata or construct an IBIS expression, etc., is actually prohibitively expensive. There's a couple of interesting tools and kind of techniques that we're going to go through here. So let's get started. I've set up a main function, and I've kind of made a goofy little runner here. And if we go over to IPython, we can use the run magic. Let's first actually define the URL. We can use the run magic to run our getschema.py file, and we can give it the URL. And you can see it does nothing right now because the main function is empty. So let's just make sure that, for sanity, that we're actually doing something. Okay, so we're printing out our URL. Good. So our function is actually being called. It's just not yet doing anything. So the first thing that we probably want to check out is, like, what does the Parquet file format look like? And I will pull that up right now. If you go to, let's see, it is the Parquet MR repo, which actually is linking me to the Parquet format repo. I'll put that in the chat right here really quick and then share that screen. Let me just add that really quick. Okay, and we will add the Parquet format info over here. So hopefully that's showing up, and I'll zoom in a bit. Whoops, go up here. And the main thing we're interested in is getting this kind of footer file metadata stuff out of here. And you can see that there's, it's a thrift-based metadata format, which there's like a whole sort of set of infrastructure and other libraries that you need to kind of automatically decode thrift. And luckily, all the folks over in the PyArrow and Arrow project have created a set of tools that make doing this easy, and you don't have to install thrift, etc., or at least you don't have to be aware that you're installing thrift. And we'll kind of get to that in a bit. But the first bit we're looking at here is the footer, and you'll see that the footer has three components. There's the footer, which contains the file metadata, which itself contains a bunch of stuff. And then directly after the footer is the length of the footer, and then a magic number at the end of the file, the last 4 bytes, PAR1. So the footer length is kind of the jumping off point here. The footer length actually just is a 32-bit integer, and it describes the number of bytes in this footer chunk here at the end of the file. And so if you were reading a Parquet file on disk, it would be fairly straightforward to extract these bytes out, right? You would look at the last 8 bytes. You would pull out the first 4 of that last 8, kind of unpack that into an integer, and then go back, 8, and then go back the number of the number of bytes that are indicated in the footer length, read up to, up to the last 8 bytes, and then, call the sort of required Pyaro function. But we don't actually have a file on disk, right? We have a URL, so we have to use, we need to be able to request a specific, byte range cheaply. We don't want to have to download the entire file just to get, the last, whatever, 50,000 bytes or something like that. So that's our first requirement. And like I said, normally no big deal if a file is local. You seek and you read, etc. It's cheap. But in a client-server scenario, and you're using where you're using HTTP, you don't have that ability. Except there's a neat feature of HTTP called range requests, which actually let you give a specific set of bytes, like a start and an end, and it will give you that range of bytes back as the body of a request, of a response. And so we're gonna leverage that feature of HTTP heavily here. The main gotcha being that the server actually needs to support range requests. So if your server doesn't support range requests, you're kind of out of luck, and you need to find an alternative. We're using the Google Cloud Storage HTTP API, which definitely supports range requests, and so we're going to use those here. The next kind of requirement that we have is that we need to be able to get the number of bytes in the file, and this is a consequence of Parquet's format being containing this the footer length bytes and the magic number at the end of the file. If it were, for example, in the header, then we could maybe avoid an extra request, but that's Parquet, that's life. We're going to live with that extra request for now. So let's actually just write our function to get the last 8 bytes and put them into some kind of useful form. So we're going to define a function called getFooter. It's going to take a URL that's a string, and it's going to return a tuple of an int, and then it's also going to return, let's just say it's going to return bytes, and that's going to be the magic number. We're going to use requests, so let's import that. And like I said, the first thing we actually need to do, we'll just start notating that here, is get the length, get the number of bytes in the file. We don't actually need to request the whole URL to get this. Like we can use an HTTP head request, which will give you back a header in the response called content length, which is the number of bytes in the content of that URL. Request is a head method you can use for this. So we will call requests.head. If I were actually going to use this in some kind of user-facing system, I would probably call raise for status. Since I've already written it here, I'll leave this one in here, but for the rest of this, I won't be using that. And that will basically raise an exception if there's an error indicating HTTP code 400, 500, etc. The next thing we're going to do is pull out that header. We'll call it raw n bytes. It's coming back as a string, and so we're going to need to convert that. Content length. Request has a special dictionary type for the response and request headers that allows you to use case-insensitive strings. We'll call this n bytes, and then we'll just say raw n bytes. So let's see if this looks close to the 75 megabyte size that we expect. Let's run that. Okay, well, I made a mistake in typing, which I would have seen if I paid attention to the things that I cared about. And of course, I'm not calling getFooter, so let's actually call it and stop printing our thing. Okay, so we got something that looks like 78,560,000, blah, 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 etc., and some change. that's pretty close to what we kind of expect, our metadata to look like. So I have this data set locally, this Parquet file locally, and I'm just going to see um, what that looks like. So it's 75 megs. Let's see what the byte count is. Okay, there's some additional discrepancy here. Not entirely sure what that is. It's possible some calculation in DU is slightly different for this. Another thing we can do is like literally just open the file, read the bytes, and then we want to open it in that mode, binary mode, see how many are in there. Okay, so it's 78 million, so blah, blah, blah. It's that same exact number of bytes that we see coming from that range request. And we didn't actually need to download anything, which was really nice. So, like I said, we're going to use range requests. And since we're going to be kind of making those range headers pretty often, I'm going to make a function that's going to construct the right header dictionary for me, given a start and an endpoint. The way that you specify a range request is using the key range, and then followed by a string that says bytes, and then you give it a start and an end. You have to be a little bit careful here because the end is inclusive. So if I want bytes, 0 to 1024, I need to actually pass 1023 because the endpoint is inclusive. This can be a little bit tricky if you need to do some calculations like we're going to have to do in a bit, because if you're using Python or you've been using it for a while, it's zero based, and the endpoints of slices, for example, are exclusive, and so just need to watch out for that. In fact, when I was implementing this the first time, I made an off by one error and was getting all sorts of bizarre behavior. Okay, I'm also going to make a Parquet magic byte string, and we're going to make an assertion about the last 4 bytes here to make sure that we actually are reading a Parquet file. This is not really like something you would ever present to a user, I guess depending on who your user is, but for like a data analyst, like this is like not anywhere in there near what they're kind of interacting with. All right, so we've got the number of bytes in the URL in the file, and the start point. If you remember, ooh, I just realized this whole thing has been covered the entire time. So let me just nix that. Just to recap, because apparently that's been covering the stream, so I'll just give a brief recap. We made a range header function because we're going to be making these range headers over and over again. We created a get footer function, which has we're going to get the response, which from a head request. We're going to get the raw bytes from content length. We're going to convert the string that comes back from that header into an integer. And now we're at the point where we are going to figure out how to get the last 8 bytes using a range request. Okay, so we've got our response, which is not super useful. So to get to the position of the the last byte, the last 8 bytes, the starting point of the last 8 bytes, we go back 8 bytes, of course. And then if like we were using a Python slice, of course, we could just say n bytes, and that would be the end of the story. But like I said before, we've got a range header has an inclusive endpoint, and so we need to actually subtract 1 from that because it will include the last 8 and then that last byte. And then we're going to make another request, get URL, and then we're going to pass headers to the get function. We're going to call our range header function, which is going to make our dictionary for us. And then we're going to say start and end. If I can spell requests. I'm going to format that And now the content, right? The content is the raw content from the response. So we're just going to assign that to a variable, and we're going to assert that the length of the content is 8. And hopefully, I don't have to put my foot in my mouth here, and that will be, we will still see the number of bytes printed. Great. So we did in fact read 8 bytes. The next assertion that we can make is that the last 4 bytes are equal to our Parquet magic. Let's check that. Cool. And then now the question is like, what? Let's just like look at the first 4 bytes of content. So we have this like random looking byte string of junk, and this is actually just the raw bytes of a 32-bit integer. And Python, being the great batteries included language that we all know and love, has a module for dealing precisely with this kind of problem. It's a little bit arcane in some ways, but it is pretty useful in this context. So we don't really need to sort of futz with the magic number here. We're just kind of leave that alone. But we're going to use the struct module. I'm going to import it up here. Import struct. If I could spell, that would be nice. And then there's this function in struct called unpack. And if you look at unpack signature, it's got a format, which is a string or a byte string, and then a buffer with some, opaque readable buffer type. The readable buffer is just indicating that you don't have to give it a byte string, but you can give it, say, like a bytes IO or something similar, a byte array. But the first argument is the format string, and this kind of indicates how you're going to tell Python how to read the data in the second argument using this format string. You probably want to check out the struct module docs to see the full set of format strings that you can use. Let's see. But we already know that there's a 32-bit integer there, and the code for that, I'm just going to kind of pretend that I magically know that, and but you should take a look at the struct module docs to confirm that. And then there's you can say S for string, but that will only read a single character, and so what we actually want to do is read 4 characters. So basically the I is the first 4 bytes, and then 4S is 4 single bytes. And so this will turn those wacky looking length 4 byte string into an integer, a Python integer. It's no longer 32-bit, but it's a Python integer. And then we can actually start to extract the metadata from this particular file. So we can move this assertion here and say magic equals Parquet magic. And then we can, let's say we're going to return, we actually are at the point where we can return this now. And we can return footer length and magic. And like we said before, we have a tuple of int and bytes. And let's just print out the footer length to make sure things kind of look sane. Okay, so I did something wrong, which was I didn't pass in the second argument to struct unpack, which is pretty essential. Okay, 50,000 bytes is the length of the footer. It's kind of hard to tell exactly like whether that's reasonable, but if you get something ridiculous like a negative number or some huge number that would just never fit in memory on your machine, there's probably a bug somewhere. So 50,000 bytes looks fairly reasonable. Parquet metadata contains things like you saw earlier in the video. It contains, like metadata per row group. There's metadata per column. an author of a Parquet file can put kind of arbitrary data in there, so they can be arbitrarily large. Um, and so it's hard to tell exactly what's a reasonable size. But this looks fairly reasonable. I know this file doesn't have a ton of data in it, a ton of extra metadata, so we can kind of move on from that. Um, so the next kind of phase of this is like, well, now that we have the footer, like, how do we turn that footer into, like, how do we turn that kind of into a schema, right? We have the length of the footer, but we don't actually have the footer data yet. We have the magic number and we have, the footer length, etc. So we're going to need another function. Actually, first let's assign the footer length magic. We don't really need the magic number for anything after we've kind of verified that the footer that the magic is what we expect it to be. So we're just going to return the footer length. We should really fix our signature here. Cool. I'm going to keep this as a tuple int and return the number of bytes because we're going to need that later. So let's say footer length n bytes. And now we've got our footer info. Let's see what we're going to do next. So the next thing we're going to do is get the actual footer bytes, not just the length or the number of bytes. We're going to actually get the footer bytes. So remember before, we need to figure out kind of the start, and the end byte range numbers, the boundaries. And we know that this is the number of bytes. So this is like the last possible thing you could read. We already know that 8 bytes are going to be the footer, like the information about how to get access to the footer. And then now that we have the footer length, we need to go, back that number of bytes to actually start at the footer. So that's the start offset of the footer byte range. And then, of course, we can go back 8 to get to that first byte of the last 8 bytes, but we need to go one before that because of our inclusivity on the range request. And the thing that we kind of want to make sure here is that the end minus the start plus the byte that we need to account for the inclusivity is equal to the footer length. And of course, you could say something like, okay, your math is wrong here. So let's run this function and just make sure that there's effectively no output. Great. So our assertion's passed, and we have our start and end byte ranges of the footer. So the next thing we're going to do is make a GET request to that same URL. We're going to assign headers, and we're going to make our range header. Range header, start and end. That's going to give us back some content. And like, what is that content? This is the footer bytes. And it contains the information to contains the schema information among other things. We're only interested in the schema information for the purposes of this stream, so that's what we're going to focus on. The next thing that we are going to want to do, and that's like where kind of PyArrow really shines here, is we're going to call this like pyarrow.parquet.read metadata. And it's like, well, what actually goes there? Well, read metadata, if you look at its signature, well, okay, it's any, but that's probably because I haven't imported PyArrow. Let's just make that a bit more concise. PyArrow.Parquet as PQ. We'll go down to that and we'll make it short. Whoa, make it short, and then we'll do that. And then hopefully we'll get, okay, we're not getting any more useful information there. That's fine. But read metadata accepts files, buffers, and maybe other things. I don't know exactly. For our purposes, we just need to leverage the fact that it accepts buffers. And of course, in Python, we can create a blob using IO bytes IO. Of course, we haven't imported that yet, so we're going to import IO. Okay, let's format some stuff. Got a question mark here causing a syntax error, so we're just going to put some dots there. The first thing we're going to write is blob.write, and we're going to write in the content. Now you might think, well, is that enough? Like, well, we first have to pass in blob to read metadata, and then we can return metadata.schema, because we know that is the attribute we're after. Let's see what happens when you do that. Well, if I could spell requests. So here it's like arrow invalid, Parquet, magic bytes not found in footer. Either the file is corrupted or this is not a Parquet file. We know that it's a Parquet file, or at least we know that we saw the magic number in the last 4 bytes, and we're using that as a proxy for being a Parquet file. And it turns out we actually also need to write like this sort of the raw footer info as well, because the read metadata function expects that to be there. Even though we've already kind of extracted a bunch of stuff and it's a little bit repetitive, this function still expects those bytes to be there. It's actually validating that as a Parquet file for you, which is pretty nice. So we need to actually somehow get that. And we're getting it in the footer, so we can return it there. And we can just say content here, and we can call this raw footer info. And hopefully that's all we need to do. Well, we got something, but I didn't actually print it out, so let's assign that to a variable. Or I should say we didn't get any errors. It's not clear if we got anything, but let's see what that looks like. Okay, so we got something pretty nice. This is like kind of the raw Parquet schema, repeated required groups. This is kind of exposing some details about Parquet, but you can see there's fields, etc. It's not giving you sort of column names, but we could let's see, we could probably actually don't remember how to get this from. Do we have these variables in scope? Oh, sweet. Okay, so now we can say to arrow schema, and that actually gives us something incredibly useful, right? We have the column names, the types. Kind of what more could you ask for? So that is how you use range requests and PyArrow to cheaply access the metadata of Parquet files in URLs. Thanks for tuning in. Hopefully the covering of the format for some of the beginning of the code is not too prohibitive. Thanks for tuning in. See everyone next time.